Hello, Professor and TA. My name is Prajna Nayak, and this is my midterm report for the subject Introduction to Systems Engineering. And my topic is satellite communication. So, let's begin. These are the topics for today, and I would introduce you firstly to a satellite communication. What is satellite communication? And before that, what is actually systems engineering about? And then we'll dwell into satellite communication. And then the topic of study for today in satellite communication, which is Starlink. So we'll understand the requirements of Starlink, how Starlink actually came about, and what challenges did it face, and how it went through right from the ideation stage and until the deployment stage. What was the challenges and what went through the entire Starlink journey. So let's take a look at firstly understanding what is systems engineering. Systems engineering is a multidisciplinary engineering field in itself, and it is used mainly when the project is too complex or sophisticated. Let's take, for example, to develop an electric vehicle or to plan a water system for the entire system or for the entire city. So, it's a very broad and complex subject integrating different departments of the system within itself and also allowing interactions and understanding interactions within the external environment. So, systems engineering can be very sophisticated and subtle as there are many technical and non technical interfaces involved, which make the system more and more subtler and delicate to handle. So there are a lot of trade-offs involved when we deal with a subject so as to what kind of components should be used for maximum, performance. But if we get this maximum performance, are we losing out on so many other factors? So it starts basically the study of trade-offs and we understand what is good for the system, what is not good for the system, and the other parts of the system. So it is a study of trade offs and multiple decisions that are made, and then we finally choose the best probable one among the auction pool we have. So, this is what systems engineering is about. So, now let's understand the topic of satellite communication. So, firstly, let's understand what is satellite. A satellite is a smaller object that revolves around a much larger orbit object. So, simply stating that it revolves on the earth and can be sun and moon. Satellite revolves around the earth and moon, and Starlink is an artificial satellite. Sputnik is an artificial satellite. HugeNet is an artificial satellite. These are all artificial satellites which are sent into space. And certain Earth movements to understand the movements of the Earth or to provide some services like internet, voice, radio. And these are the concepts of two types of satellite communication. There are two types of satellite communication, that is, natural satellites and artificial satellites. And the frequency which communicates with the satellite from the Earth is the uplink, and the frequency that is called downlink, that which communicates with the Earth station from the satellite. So, now let's understand why satellite communication. Why do we need a satellite out in space to communicate? Why can't there be just ground wave communication or some other kind of communication? Why do we need satellite communication? So, for this, let's understand the different types of communication or propagation. So, there are various forms of communication, like we can see ground wave propagation, sky wave propagation, and scattering wave propagation. So, ground wave propagation is very much signal that travels closer to the curvature of the earth. So, it's very close to the surface of the earth, whereas skywave propagation gets reflected from the F layer of the ionosphere and scattering wave propagation gets reflected from the E layer of the ionosphere. So, from these types of communication, we can understand is there is a basic requirement of Earth. We are totally dependent on the Earth or the surface of the Earth for the atmosphere with the ionosphere within the E layer or the F layer. And we are totally dependent upon the curvature of the Earth for the signal communication. But in case of satellite communication, the satellite is up in the space and we relay signals right from our ground stations, right from Earth, and there is no interference or no requirements of the curvature of the Earth. So, that is why there is a valid requirement and a need for satellite communication. Moving on, now let's get to the case study of our satellite communication, which is Starlink. So, Starlink, so I'll tell you a fun fact that this is the line of constellation on the side. This line of 60 constellation which have been launched by SpaceX on Falcon 9 rocket. On the 20th month. So yeah, May 24, 2019, this is the photo of that. So let's now understand a bit more about Starlink. What is Starlink? How did the idea come about? What is the idea behind Starlink? And what exactly Starlink was named after? So, Starlink is an internet constellation and it is operated by SpaceX. So, this basically aims at giving global coverage and promises to deliver high speed internet connectivity, especially in the rural areas where connection is, unreliable or completely unavailable. Even in the US, about 1.5 million people, have no internet connection, that is broadband connectivity. And I'm talking about when we actually look at the big spectacle of the world. And this is a very huge market that Elon Musk or Starlink can think about. So, providing high speed, low latency, and low cost internet is the major thriving game factor, I'd say, for the establishment of Starlink. So, Starlink initially was started in 2012, and then they had their plans to change up a bit. And no, they also planned a launch which did not happen later, and maybe then later. They planned to launch, which happened in the year 2015 with the help of Tintin A and Tintin B. And then in 2019, Starlink with the help of Space Basics. So now let's talk about system engineering phases and bit more technical. So as you can see in this slide, this is a V model which is a common graphical representation of system engineering life cycle. So, the system engineering life cycle is valid for any systems engineering project. But for this, we'll be talking about the Starlink approach. So, generally, the left side of the V is all about concept development and composition requirement. What is the architecture of how the architecture should be of the system, the physical architecture that can be put together. And right side is usually involving test validation, integration of these different entities. So this involves a systems engineering phases. So we'll understand in detail in the new course of this report until the final report that how Starlink has managed to put this ideation phase to deployment and successfully launching the number of satellites it did and is still launching every week as we speak. So yes, let's get into the detail. So, the first stage of any systems engineering life cycle would be the concept development. I mean, concept development, as the name suggests. How did this concept development? What is the basic idea or motivation behind this? And also, it involves analyzing how the system as a whole will react or interact with the external environment, and also how the system within will interact with different components. So, concept development involves how it's going to react and what are the alternatives. Is there any better system available? Okay, so if there is a better system, why choose this one. So we find out what alternative options that we can prioritize our needs, because obviously you can get carried away in due course of the project, but you have to prioritize your stakeholder and operational needs. You know your challenges, and based on that you only get one or two solutions, and you pick the right one. So the concept development stage can be subdivided into three parts: need analysis, concept exploration, and concept definition. So now let's talk about need analysis. Need analysis, as the name suggests, it is the primary objective to show that there is a valid need and an open market for this proposed new system, and that do over the older one. So, why is it that this system has to be built in the first place? Isn't there a previous predecessor already available? If so, what are the major advancements you are doing to surpass this predecessor? So there can be two types. New system generated one is based on the need driven, that focuses on developing a new system as there are obvious flaws. So we need to do it anyway. So we'll have to do it, so that's a need driven system. And a system, because there is something advanced technology wise, we can produce a better output or have a better performance as compared to the previous predecessor. So there's a better option for users. So this technology driven. So now let's understand how Starlink's approach was towards internet communication. Was it a technology driven approach, or was it a need driven approach? So, Starling's approach towards the need analysis was based mostly, both a need and also a technology driven approach. The reason being internet connection. In the 20th century, as we speak, it is available to all. But the unfortunate situation is that it is still not available to all, and there are certain untapped markets out there which can only be achieved by our technological advancements, which can make internet communication in those regions possible. So, this was a need and a technology driven need, because there is a need for internet communication, technology driven, because Starlink was maybe one of its kind to launch satellites, especially in LEO, that is the lower orbit of the Earth. Usually, satellites are launched into geostationary orbits, which are like 35,000 kilometers away from the surface of the Earth. But LEO is just 1200 kilometers away from the Earth. And there is also another part which is MEOW, that is medium Earth orbits, which are like probably 35,000 to 20,000 range from the surface of the Earth. So there were many geostationary satellites launched into space for the purpose of internet connectivity, radio signals, and all kinds of communication. But Starlink is one of its kind. So there's a need of internet connectivity where the connection is unreliable sometimes. Even though there are satellites in geostationary, orbit, it depends upon the location on the earth where your internet is working or not. And that's the problem. Starlink is trying to eradicate the location on the earth, and not a problem we are trying. Starlink is trying to figure out how to place the location of the satellites with respect to Earth, so that everyone on the Earth receives internet connection. So I think that concept is very beautiful in itself, and there are obviously many challenges involved with those concept which can later get into. But yeah, this is the basic need why Starlink actually came into play. And I just wanted to mention that Starlink has this awesome goal of internet from space, which obviously is the communication from satellite, and has, compared to the competitors like YSAT or Dubsnet, it's easier to install for a user, as there is nothing for us to install, and is more cheaper in comparison to manufacture the satellite. And the speed is obviously way better as the latency is reduced. The satellite is just 1200 kilometers away from the Earth. So, yeah, the speed is never an issue. Yeah, that's all I wanted to point out. So, this is the next stage of the systems engineering life cycle, which is the concept exploration subphase. So, concept exploration subphase uses the output from the need analysis subphase and continues to work on top of it. So, what it does is it converts the operational viewpoint of a system to an engineering viewpoint, which is required in all the systems engineering phases. So, what it essentially does is this means it provides an array of selections available or an option pool which can be materialized into concepts that can be evolved into a physical model of system, which can be evolved into exploring different concepts and understanding what system does. Evaluating the concept of this system is what concept exploration is all about. So, concept exploration in terms of Starlink, the objective of Starlink was clear. We need to provide internet to all parts of the world where connections are really unreal, unreliable, or unavailable just because of the location. So, that was the major objective of Starlink. So, Starlink initially launched, constellation prototypes which are named Tintin A and Tintin B into space. There were actually piggy tech paybacks, spay of Spanish satellite, and I think the name was PES. This was a communication satellite, so it was called piggyback payload on that. This was launched. These two were launched on Falcon 9. So Tintin A and Tintin B were initially launched to understand the movement of the Earth, to understand the movement of the space, to understand how Tintin A and Tintin B will be reacting with respect to Earth and with respect to space debris. And with these definitions of readings and understanding they got from Tintin A and Tintin B, they redefined and the satellite design further, which helped in successful deployment of Starlink, which later happened in 2019. So now, the next stage of the system engineering life cycle is the concept definition. It is the subphase that entails the selection among the pool. That is, amongst the best alternative, there'll be an option pool and there'll be decision trees made based upon the capabilities and the function that the system does. So, based on that, via various case studies, a final decision is made. What is the definition of this concept? What is it doing? What does it do? Aim to do, and how does it do? What will it do, and what is the cost of doing it? When will it do it, and what kind of risks are involved? Defining the entire system at this stage, so you can see there are four stages for this: operational performance and capability, program cost, program schedule, and also the risk involved. So ultimately, this is what we are doing: defining system, what Starlink actually does, what does it do to the environment, what kind of rig does it provide, and what does it do. So, Starlink, while defining the concept of Starlink, physically is made up of certain laser links. There are about four laser links within the satellite which are connected, which are embedded within the satellite and helpful so they can communicate with each other. That is, let's just assume that one of the Earth ground station has been damaged. So this does not mean the satellite in space cannot communicate with the satellite. It can relay to the next satellite which is in the orbit, and the satellite can communicate if the signal to its corresponding Earth station. So this relaying can be done in space, which this system is actually mimicking the present optical fiber connection of the Earth. So this connection of network is actually Starlink is, and this has also raised certain advancements in terms of long term communication, that is long distance communication. I mean, because as if someone has to call from California to say, let's say, India, there is certain route underground which the call has to follow. But if it's the wireless everything, if wireless call is happening, that is, reducing latency. So it's amazing as a customer and as a speed enthusiast. It's amazing. There are pros and cons for every system we define and build. As the latency is very less, this is because the satellite is placed in an orbit which is very close to, that is 1200 kilometers away from the surface of the Earth. So at this level, there's always an effect of the Earth's atmospheric drag. So, the drags of the Earth's atmosphere can cause the satellite to flame up into flames, and this can cause the space debris. So, we know that various kinds of space debris collision prediction and technology has been kind of data fed into Starlink satellites which avoids natural space debris which can just break the satellite. This is the kind of technology they use. They automatically just move here and there to avoid obstacles on space. So, but still, there is always a risk of satellite collision, and with the number of satellites being launched, especially by SpaceX, there is also subject of light pollution. So, astronomers are saying there is a lot of light in space being generated because of these satellites. So, yeah, there is a risk which we'll be talking about in the challenges part. So, as you can see, I already said in the previous act that satellite collision is one of the challenges that Starlink has faced, and it's actually saying Tintin B, which is Tintin B is the second constellation of the prototype, has already orbited, and B orbited into Earth's surface with the help of krypton thrusters, and is now nothing remains of Tintin B have been found, so that this essentially means satellites might collide with other satellites. So, the other kinds of space debris. So, we have to understand this right. In vacuum, even just a small amount of paint which is traveling at the speed of light can destroy a satellite. So, like a blade. So, at this speed, when a satellite gets destroyed and in vacuum, obviously, this destroyed satellite will further destroy satellite. So, this leads to a big space garbage waste. And this is what Kessler syndrome is all about. So, the cost of launching satellites into space is always into billions. This is always, the fact that the cost of launching satellite is into space is always a mission which is cost billions, but unfortunately, the backing of SpaceX has launched the Starlink satellite on Falcon 9, which is itself a reused rocket. But yes, it doesn't change the fact that there are a lot of money, being pumped into the system. And if speculations go here and there, if the system doesn't turn around as it should, the money is gone into drain. So that's one factor. Thank you so much for listening to me patiently. This is it for the midterm report. Thank you so much for your time.